This lecture is about learning to rank. In this lecture, we're going to continue talking about web search. In particular, we're going to talk about using machine learning to combine different features to improve the ranking function. So the question that we address in this lecture is how we can combine many features to generate a single ranking function to optimize search results. In the previous lectures, we have talked about a number of ways to rank documents. We have talked about some retrieval models like BM25 or Query Likelihood. They can generate content-based scores for matching documents with a query. And we also talked about the link-based approaches like PageRank that can give additional scores to help us improve ranking. Now the question now is how can we combine all these features and potentially many other features to do ranking? And this will be very useful for ranking web pages. Not only just to improve accuracy, but also to improve the robustness of the ranking function so that it's not easy for a spammer to just perturb one or a few features to promote a page. So the general idea of learning to rank is to use machine learning to combine these features, to optimize the weights on different features to generate the optimal ranking function. So we will assume that given a query document pair, Q and D, we can define a number of features. And these features can vary from content-based features, such as a score of the document with respect to the query according to a retrieval function, such as BM25 or Query Likelihood or Pivot and End normalization or PL2, etc. It can also be a link-based score like PageRank score. It can be also application of retrieval models to the anchor text of the page. Like those are the text descriptions of links that point to this page. Right? So these can all be clues about whether this document is relevant or not. We can even include a feature such as whether the URL has a tilde, because this might be an indicator of a home page or entry page. So all these features can then be combined together to generate a ranking function. The question is, of course, how can we combine them? In this approach, we simply hypothesize that the probability that this document is relevant to this query is a function of all these features. So we can hypothesize that the probability of relevance is related to these features through a particular form of the function that has some parameters. These parameters can control the influence of different features on the final relevance. Now, this is, of course, just an assumption. Whether this assumption really makes sense is still a big question, and we still have to empirically evaluate the function. But by hypothesizing that the relevance is related to these features in a particular way, we can then combine these features to generate a potentially more powerful ranking function, a more robust ranking function. Naturally, the next question is how do we estimate those parameters? How do we know which features should have a higher weight and which features should have low weight? Right? So this is the task of training or learning. Right? So in this approach, what we will do is to use some training data. Those are the data that have been judged by users so that we already know the relevance judgments. We already know which documents should be ranked high for which queries. And this information can be based on real judgments by users, or this can also be approximated by just using click-through information, where we can assume the clicked documents are better than the skipped documents, or clicked documents are relevant and the skipped documents are non-relevant. So in general, we would fit such a hypothesized ranking function to the training data, meaning that we will try to optimize its retrieval accuracy on the training data. And we can adjust these parameters to see how we can optimize the performance of the function on the training data in terms of some measures such as MAP or NDCG. Right? So the training data would look like a table of tuples. Each tuple it has 3 elements: the query, the document, and the judgment. So it looks very much like our relevance judgment that we talked about in evaluation of retrieval systems.